I hope all of you are doing great today. Now, on today's episode, we are going to learn about the banker algorithm. Now, it is the concept that is mainly used in the operating system. Okay, at first, we have introduction. The banker algorithm is the deadlock avoidance algorithm used to allocate the resources to process in the computer system, ensuring that the computer do not enter into the deadlock state. It was introduced by the ITSR Dijkstra and primarily used in operating system to handle the multiple process and the resources allocation request. The algorithm stimulate the allocation of resources to the process and check whether each allocation leaves the system in a safe state or not. If the system is in the safe state, the request can be granted. Otherwise, the request is denied. What is safe state? The safe state is one in which all the processes in the system can complete their execution without causing a deadlock. The system in the safe state, if there is at least one process that can finish execution, release its resources, and allow other processes to eventually complete their execution. If there is no sequence of the process that can complete successfully, if some processes are stuck waiting for the resources that will never be released, the system is in unsafe state. Components of the banker algorithm available a vector representing the available instance for each resources, max or matrix representing the maximum demand of each process first for each resource type, allocation, a matrix representing the current allocation of the resources to each process, need a metric that represents the remaining resources need of the each process. This is calculated as need max minus allocation. Now, safety check. The safety check is one of the banker's algorithm. It works by determining whether the system is in the safe state or not. After the resources request is handled, the algorithm perform the following step. Let the work vector be initialized as the available vector, which represents the resource available. Let the finish vector be initialized to the false or the for all the process, indicating that no process has completed it. Find a process with resources need can be met. Find a process if p that is the any remaining need is less than equal to the work vector. This means that resources required by the process p are available in the system. If such a process is found, it is assumed to complete its execution and release its resources, which will then be added to the work vector. Repeated the check. Repeat the above state until earlier the process are finished or no such process can be found, which indicate as an unsafe state. Also determine the safety. If all the process finish, the system is in safe state. If the process can finish, the system is in unsafe state. Step in the banker's algorithm. The banker's algorithm works by handling resources request and then determining the system remains on in the safe state after granting the request. The steps are request for the resources, when the process maximum requirement, if the system proceed to check if the system remains is in unsafe state after granting the request, grant or the deny request, the system tentatively grant the request and update the available resources and allocation matrix. After that, it runs the safety algorithm and check whether the system is in still safe state. Also, if the system is in the safe state, the request is granted. If the system is not in the safe state, the request is denied. The process has to wait. Example of the banker's algorithm. Let us work through the example to explain how the banker's algorithm works. There are five processes: P1, P2, P3, P4, and P5, and three type of resources ABC. Evaluate resources 332 allocation matrix allocation 0 2 3 2 0 1 0 0 1 0 0 0 2 1 2. Now the max matrix max is equal to 7392452 023 322223. Now the need matrix max minus allocation need 71604 42013 Now the request resources, suppose process P1 request resources 102, then the system checks whether the request is less than 0 or equal to process need request for P1 102. The request is less than or equal to the need for P1. Now the system check if the request can be granted by verifying whether the resources are available. Available resources 332. The request 102 is less than or equal to the available resources, hence the request is granted. Update resources after granting the request. The system update the available resources and the allocation matrix. Now the available resources available 332 minus 102 230 allocation 123201001020212. Now the safety check initialization work available 230 finish false 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 check process P1 need P1 641 which is less than or equal to work 2300, so P1 cannot finish check process P2 need P2 122 which is less than or equal to work 230 or P2 finish and its resources are added to work work 230200430 finish true false false true repeat all the other process until the process finish. The Banker's algorithm is a powerful tool for managing the resources in the computer system and ensuring that the system never enters an unsafe state, whether the deadlock could occur by stimulating the resource algorithm and checking for the safety. The system can prevent deadlock and allow for fair and efficient resource management. The algorithm is critical in the system that requires C-level resources algorithm like banking, real-time system, and multitasking operating system. However, it requires extensive knowledge of the resource availability, process need, and system state, making it more complex to implement than the simpler resources allocation algorithm. Okay. Again, we will read about the complex. Make it more elaborate it also. Now, again, we are going to discuss about the banker's algorithm, evaluate resources, maximum need time, roaming need time, also safe and unsafe step. The banker's algorithm works. How does this kind of algorithm works? Request for the resources also. Stimulate the safety check also. Initialize file process. Now the grant DNA request assumption also. Resource maximum. Okay. Allocation. Banker's algorithm is important tool now. Banker's algorithm concept need max minus allocation. How does the Banker's algorithm works? The banker algorithm is the decision making. Now, how does the Banker's algorithm works? The Banker's algorithm is a decision-making process based on the safety check, determine if the granting resources will lead to the safe or the unsafe state. Also, initialization, the system keeps the tracks of available max allocation need matrix. The available matrix indicate the number of available resources of each type. The max matrix represent the maximum demand of each process for each resource type. The allocation matrix indicate the number of resources already allocated to each process. The need matrix is derived from the matrix and allocation matrix and tells the system how much more resources can each process require. Whether the request does not exist, the process maximum demand, whether the request resources are less than or equal to the currently available resources. stimulate the algorithm, the system can then pretend allocate the resources of the process. It update availability matrix by subtracting the resources request by the process. The allocation matrix is also updated by adding the resources to the process allocation. The need matrix is updated by subtracting the resources granted from the process remaining is need another. Safety check after the stimulated allocation, the banker's algorithm performs a safety check to determine if the system is still in safe state or not. The safety check works as follow. Initialize org vector, which start as a copy of the available vector representing the resource available after the allocation. Initialize the finish vector, where each element is initially set false to indicating that process has finished. The process PY sorts the remaining need to process from the need matrix is less than equal to a current worker vector. This means the process pi can complete and release the resources. If the process is found, stimulate its completion by adding its allocated resources to the vector and making the process as finished. Repeat the process. If all the processes are marked as finished, then the system is safe state and the request can be granted. If the no process can be found, the system is in unsafe state and request is denied. Grant or deny request. If the process is in safe state after the allocation, the request is granted. If the system is in unsafe state, the request is also denied. Banker's algorithm example. Let us consider small example to better understanding of the working of the banker algorithm. The system has the three type of resources A, B, and C. The five processes are P1, P2, P3, P4, and P5. Available resources 2332, maximum max matrix 73924520233 and allocated resources allocation matrix 023200001000212. Need matrix max allocation need 716044201332011. Request for the resources. Let us say that the process P1 request resources 102. We check does the request resources 102 exceed the need for P1? No, because P1 need for the resources 743. Does the request 102 exist? Available resources? No, because available resources is 332. Stimulate the allocation after granting the request. The new available resources will be 332 minus 102,230. Allocation 123201001020212. Safety check. Oh, 230 finish false 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 false. The system try to find a process that can finish with the current resources. Also PN cannot finish because it needs 643 is greater than work 230. P2 can finish because it need 122 is less than or equal to work 230. After P2 finish, the resource is allocated to the P2 and added to work 230200430. The banker's algorithm is an important tool in the deadlock evidence that ensures the safety resources allocation in the multi-processes. It provides an efficient way to prevent the deadlock by stimulating the allocation of the resources and ensuring that the system remains safe state. While it requires the advanced knowledge of the maximum resources requirement of the process, it play a critical role maintaining the system stability and ensuring the fairness in the resource distribution. Make more answer with QUST. Now, what is an operating system? An operating system is the uh, an operating system is a computer software that manage computer hardware software resources and provide the common service for the computer program. So operating system act as an intermediary between the user and the computer hardware. Or types of operating system batch processing. Operating system and the batch processing jobs are collected, grouped together and executed without interaction with the user. It processes job sequentially one after another. Example, IBM early mainframe time series of operating system. This type of operating system allow the multiple user to access a computer system concurrently, each with a limited amount of the time on the CPU. It uses the time slices for the process management. Example, Unix. Distributed operating system. It manages a group of the independent computer appearing as a single system to the user. It allows for resource sharing across the multiple machine. Example, Google's Android operating system in cloud computing environment. Network operating system provides service to manage the resources across the network of the computer, enabling the communication and the file sharing. Example, Novel Network, real-time operating system RTOS, an operating system designed to respond to the not within the specific time, usually in the environment where the real-time processing is critical. Example, BS works. Explain the function of operating system. Primarily process management. The operating system handles the creation, scheduling, and termination of the process. It ensure the process run smoothly and the CPU time is allocated efficiently. Memory management, the operating system manage the system memory, allocating and deallocating the space to the process, ensuring that this process has enough memory without overlapping. File system management, it manages the file and directory, including creating, reading, writing, and deleting the file and managing their access right. Also, device management, the operating system control hardware device through the device driver and provide an interface for the user program to interact with the hardware. Also, security and access control, the operating system ensures the security of the system resources by authenticating user and enforcing access control policy. User interface, provide an interface command line or graphical for the user to interact with the system. What is difference between logic address and the physical address? Logic address, this is the address generated by the CPU during the program execution. It is the part of a program virtual address space. Physical address, it is the actual address of the memory at hardware RAM. It refers to an actual location in the system memory. The difference between the logical address is used by the program while the physical address is used by the memory hardware. Also, logical address are translated to the physical address using the memory management unit. Explanation of the process swapping in the operating system. Swapping is the memory management technique whether the process is moved between the main memory and blocking store, usually a disk, to free up the memory space for other process. It allows more process swapping, moving process from the disk to the memory, swapping out, moving out process from the memory to the disk. What is deadlock? A deadlock is the situation in which the two or more processes are blocked and unable to proceed because each process is waiting for the other to release resources. Mutual exclusion, at least one resource is held in the non-shareable mode, meaning only one can process use at a time. Hold and wait process of holding one resources is waiting for additional resources. No prescription resource cannot be printed. Circular wait. What is the paging and operating system? Paging is a memory management scheme that eliminates the need for the continuous memory allocation where the process need the memory the allocated page. Operating system advantage of the paging, eliminate the external fragmentation, easier to allocate and deallocate the memory. Disadvantage, internal fragmentation can occur. The size of the process does not match the size of the page. Page table management, explanation, request validation, stimulate allocation, safety check. The available resources are initially 3 to 2. The maximum demand and allocation for each process is given in the matrix. The what is the semaphore? Semaphore is the synchronization tool used to manage and assess the resources within the concurrent programming. It is essentially an integer variable that is used to control access to the critical section. Binary semaphore counting semaphore, the limitation of the semaphore, deadlock, priority inversion, race condition. What is disk scheduling? Disk scheduling is the process of determining the order in which the disk I/O requests are proceed. The goal to minimize the average seek and the time and the for improve the overall performance. FCFS, the algorithm process disks require the order they arrive. It is the simple but the inefficient due to the long seek time. Forces are fair STSS. The disk head move to the request that is closest to its current position. Scan, the disk arm moves within one direction. Scan, similar to the scan, but when the disk arm reaches at the end, it jumps back. Okay. What is file management? File management refers to the process of storing, organizing, and managing the file in the system. It includes the creation, deletion, reading, and writing. File allocation, continuous allocation. In this method, file are stored in the continuous block of the memory. It is fast for reading and writing, but it suffers from the fragmentation and wastage of the space. Linked allocation, each file is stored in the non-continuous block and each block contains the pointer. The method eliminates the fragmentation but requires one more time. Okay, index allocation is file has the index allocation that is store the pointer to the data. This method allows inefficient conclusion. The process and answer request provide a deeper understanding of the core operating system. Okay, This much for today.